Hi students, today we are going to start the new chapter pair of linear equation in two variables. So let's start from the beginning, only the basic. So first of all, what we have to understand the word equation. So what is the meaning of equation? Basically, you can say any mathematical statement involving equal sign. Okay, any mathematical statement involving equal sign is called what? Is called an equation. Okay, any random expression we write, for example 2x plus 3 equal to 5, equal to sign is involved, so it is called equation. X square plus 3x plus 5y equal to anything or 0, so this is called equation. In short, any mathematical statement involving equal sign is called what? Equation. Now in this, first of all, what we have to study about the different types of equation. In that, first is what? Linear equation. In this chapter mainly we have to focus on linear equation only. So what is the meaning of linear equation? An equation whose degree is 1. Equation whose degree is 1 is called what? Linear equation. Now what is the meaning of degree? Degree means highest power of variable. Okay, for example, I am writing 2x plus 3y equal to 15. Second example, I am writing 2x square plus 3x minus 7 equal to 0. In first example, you can see two variables are there, x and y. In both the power is not written, of course by default it is 1, so it is a linear equation. But in second example, we can see that x is a variable, here x power is 1, here x power is 2. But what is the meaning of degree? Degree means highest power of variable. So very clearly you can see highest power of variable is here 2, which is not 1. That's why this is not a linear equation. This is called quadratic equation. But now we are talking about linear equations. An equation whose degree is 1 is called linear equation. In these again two categories are there. First is what? Linear equation in one variable, and second is what? Linear equation in two variables. So you can understand from the name only, the linear equation, when the linear equation one variable means only one variable will be there. And what is the standard form of that, or you can say the general form of linear equation in one variable is what? Ax plus b is equal to 0, where a cannot be 0 and ab belongs to real number. Okay, so a cannot be 0. Why? Because if you putting a equal to the 0, it will become invalid statement. B equal to the 0, so you cannot say any number equal to 0, right? In general it will become invalid. So that's why we're telling a cannot be 0, however b can be 0, and a, b both belongs to what? Real number. A and b both are the member of real numbers. Example C, 2x minus 3 equal to 0. If I am comparing with standard form, a is 2, b is negative 3. Second example, 5x equal to 0. If I am comparing with standard form, a will be 5 and b will be 0. That means the conclusion is what? That x power must be 1. Okay, only one variable is there and a cannot be 0, however b can be 0. So this is a linear equation in one variable, and linear equation in one variable will always have unique solution, means only one solution. For example, I am telling solve this equation 2x minus 3 equal to 0. So we have to isolate the variable x on the left hand side. So what we will do, first of all, to eliminate the minus 3 both side, we will do plus 3, right? So like that 3 can be eliminated, so 2x is equal to 3. Now to eliminate the 2 both side, we will divide by 2. So like that 2 got cancelled. So what is the answer? X equal to 3 upon 2. So what is the meaning of getting unique solution? Linear equation in one variable will have only one value of x which will satisfy the equation. Okay, so you can put x equal to 3 by 2 in this equation. You will get answer the 0. Next word coming now, linear equation in two variables. So you can understand from the name only two variable we will write here, x and y, and general form of this will be what? Ax plus by plus c equal to 0, and conditions are what? A square plus b square cannot be 0. What is the meaning of this? A and B simultaneously cannot be 0. Either A will be 0 or B will be 0. Both simultaneously cannot be 0, because if both simultaneously the 0, then A square plus B square will equal to 0. But if any one will be the 0 and other is non-zero, then automatically this condition will satisfy. So what is actually the meaning of this? A and B simultaneously cannot be 0, and A, B, C are member of real number. Okay. Now, what we have to study in this chapter, the name is what? Pair of linear equation in two variables. So linear equation in two variables we have to study, but in pair means two equations will be there. And before doing that, what I told, the linear equation one variable will have a unique solution, but linear equation in two variable will have what? Infinite many solution. Okay, there will be infinite value of x and y which will satisfy this equation. And what is the meaning of this actually? If with the graphing the linear equation, we will get a straight line. That means if you graphing linear equation in two variable, you will get a straight line, and on straight line how many points are there? Infinite points are there, right? So that's why you can say linear equation in two variable will have infinite many solution. But now what we talking about, pair of linear equation in two variable. Pair of linear equation in two variable means two equations I will write. For example, a1x plus b1y plus c1 equal to 0, and second is what? a2x plus b2y plus c2 equal to 0. Okay, so two equations are there. Now in that three cases are there. Case number one is what? If a1 by a2 is not equal to b1 by b2, then this pair has unique solution. Okay, if this, how to solve equation that we are studying, but first we should remember the condition also. Based on that also they are asking the questions. So if a1 by a2 is not equal to b1 by b2, it has a unique solution. And unique solution, the graphical scenario will be what? Two intersecting lines we will get what? Two intersecting lines. Okay, one line like this, other line like this. So you will find that both lines are intersecting only at one point, and algebraic condition is what? A1 upon a2 is not equal to b1 upon b2. Second, the scenario is what? If a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Okay, if this condition is satisfying, then what you can say? It has a no solution. Okay, no solution graphical scenario will be what? Two parallel lines. So you can understand no solution means the lines will not intersect, and if lines are not intersecting, that is called parallel lines. So graphical scenario will be two parallel lines. Okay, one line like this, other line something like this, they never intersect. And algebraic condition is what? A1 upon a2 is equal to b1 upon b2 and is not equal to c1 upon c2. And before concluding values of all these a1, a2, b1, b2, c1, c2, make sure right hand side is the 0. First write in standard form if it is not written, and then only allot the value and apply the condition. Third scenario is what? If a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then what you can say, it has a infinite many solutions. Okay, all these condition, all these the ratios are same, and infinite many solution graphical scenario will be what, two coincident lines. Okay, two coincident line means what, one line above another. If you're getting one line above another, that is called basically what, coincident lines, if these conditions are satisfying. In these also, one more terminology we need to remember. What is that? If solution exists for pair of linear equation in two variable, we talking if solution exists, whether it is unique solution or it is infinite solution. But if solution exists, then that in that case you can say the system is consistent. Okay, system is consistent means what, this is the pair of linear equation in two variable, those two equation you can consider as a system, so in that case you can system is consistent. Okay, and if solution does not exist, if solution doesn't exist, in that case you can say system is what, inconsistent. Okay, so what is the meaning of being consistent? Being consistent means solution exists. Now solution exists, so it can be unique also, it can be infinite also, but in both cases you can say system is consistent. And if solution does not exist, in that case you can say system is what, inconsistent. Apart from these, in this chapter what we have to learn, how to solve the system of equation. Okay, so what are the different methods of solving system of equations? So basically, for your information, it's not like that whatever I'm the listing all is there in the syllabus. Okay, there few methods are there, other is not there in the syllabus, but we should know as a information. So methods of solving system of equation, two main methods are there. First, the category is called what, algebraic method, and second is what, a graphical method. Graphical method means the two the equations are given, we have to draw the graph of that, and based on that we have to decide whether it is unique solution. If unique solution, then you can write the coordinates from the graph, if it is a readable, or if it is coming the coincident line means infinite solution, and the parallel lines getting then the no solution. So that we can understand by graphing both the equation. Okay, now algebraic equation, again three methods are there. First method is what, substitution method. Okay, first method is what, substitution method. Second method is what, elimination method. These both we have to study according to syllabus. And third is what, cross multiplication method, which is also known as a Kramer rules, or you can say actually the Kramer's method. Okay, by the way we have to study these two only, substitution method and elimination method. Overall in entire chapter all these things we should know. Okay, so just go through it one time again. You can see this video one or two times for the better understanding. If any doubt is there, feel free to ask in the comment section, so I will try to solve in upcoming the videos. Now in the next video I will start solving problem on this.